Hello again, Dr. Mashburn. So today we're going to continue our blood lectures by talking about hemostasis. So hemostasis, not homeostasis. So hemo meaning blood, and stasis kind of means to stop or to stabilize. So homeostasis is to stabilize the body. So hemostasis is to stabilize bleeding. And so hemostasis is fast. It's a fast set of reactions that will stop bleeding. And it requires you to have clotting factors, and we're going to talk about the different clotting factors, and also some other chemicals and substances that are released by platelets and injured tissues. And so when something is injured, a lot of chemicals are released, and that kind of calls on the platelets to clump up and causes clotting. And so there's three steps when you're going to clot blood. There's a vascular spasm, a platelet plug formation, and then the actual coagulation or the blood clotting. And so this is what this would look like once blood has clotted, and we call that a thrombus. And we're going to talk about some bleeding disorders in another video. So what this looks like visually for blood to stop once you're bleeding is vascular spasm. And remember, vessels these are tubes, so they have smooth muscle inside them, and they're going to contract and cause the vessel to become smaller. So it's almost like putting pressure on a vessel. Same thing. It's just going to contract and kind of squeeze down and clamp down to prevent the blood from continuing to flow. You're also going to get the platelet plug formation. And so when you've injured the endothelial lining of the inside of the blood vessel, it's going to expose collagen, and that causes these platelets to start to stick. So they'll start to stick. It's kind of like flypaper. And so once these platelets start to stick, they're going to start to release a set of chemicals that makes nearby platelets sticky, and then they start to stick and stick and stick. So it's a positive feedback mechanism. So remember, negative feedback is when you shut off the original stimulus. Positive feedback is when you cause the original stimulus to kind of become more active. So the platelets cause more platelets to come, and those platelets cause more platelets to come. Once you get those platelets there, you have what's called coagulation, and you get a mesh, a fibrin mesh that kind of makes a net over the platelets and kind of holds those in place and forms the actual clot. So to go into a little more detail about each one of these steps, again, vascular spasm, that's vasoconstriction of the damaged blood vessel. That's the first step. So you can see here we've got damage, and the smooth muscle just starts to clamp down, okay? And that's going to be triggered by direct injury to a vascular smooth muscle, so like a cut or a tear, so some physical injury. And when that happens, those endothelial cells, remember, anytime you've got linings of tubes, you have endothelial cells, and also pain. So when you cut yourself, that hurts, and so you have some pain reflexes or pain signals that come out, and that's going to cause those vascular vessels to collapse or to constrict. It's really effective in small blood vessels, okay? So if you cut your small blood vessels on your hand or some superficial skin, those vessels will clamp down. Large vessels, you have to put pressure on. So that's why if you have someone that's got a deep cut with a large major vessel, and they say apply pressure, you're essentially vasoconstricting for the person because those vessels are too big. They don't really vasoconstrict like your smaller vessels do. So if you have a big cut in your brachial region or femoral region, you'd want to apply pressure, which is doing the same thing essentially as the vessel itself spasming and vasoconstricting. The next thing you're going to do is you're going to make that platelet plug formation, and again, this is the positive feedback cycle. And so that damaged endothelium is going to expose collagen. And remember, collagen is is what gives a lot of things strength. We've talked about collagen when we talked about tissues. And these platelets will stick to these collagen fibers. So normally, when an uninjured vessel, those endothelial cells actually produce something called prostacyclin, and that prevents platelets from adhering. So normally you don't want your blood to clot inside of your vessel, so that's only going to clot if there's damage, okay? So now you're going to get this swelling, and the platelets are going to become spiky and sticky, and they're going to cause more platelets to come, they're going to cause more platelets to come, they're going to cause more platelets to come, and these chemicals are going to cause the vasculature to spasm even more, to clamp down even more, and cause those platelets to aggregate. So again, that's positive feedback. So once one platelet comes and releases its chemicals, that causes more platelets to come, until finally you get a large group of platelets. So now you're ready to actually add that fibrin to it. So this is where we get the word coagulation. And so now we're going to turn that liquid to a gel. Okay, so that's what the fibrin does. So it's going to reinforce that platelet plug, like putting a net over the platelet plug. And as those platelets are building and kind of stopping the flow, they're also going to start trapping red blood cells. And so again, that fibrin is going to catch the platelets and the red blood cells and just going to make a really nice net to prevent, kind of like a dam. So think about a beaver chopping down trees and they just kind of all stack on each other and stop the flow. That's basically what this fibrin's doing, is forming a dam of the platelets and the red blood cells. Now, for this fibrin to occur, that's a cascade, and we're going to talk about all the steps that are required to actually get the formation of fibrin and the formation of this net that makes the dam. And it takes a series of reactions called proagulants or clotting factors. And there are 1 through 13 of these clotting factors. These are your Roman numerals. You probably had that when you did cranial nerve, so that should be reviewed, or remember how to do your Roman numerals. And most of these are plasma proteins. That means your blood has these clotting factors in them, and so it's ready at any time when need be for clotting to occur. So the plasma proteins, the clotting factors, are already in your blood, but they've got to be turned on. And so we're going to talk about what, because otherwise your blood would just clot all the time. So they're floating around in your blood in a non-active form, and when you need them, we activate them so that you can get this coagulation. We make these clotting factors, and for 4 of those, you have to have vitamin K. And so people who have bleeding disorders, sometimes they're vitamin K deficient, and so you may have heard someone that's getting vitamin K shots, and that is to help them make these clotting factors. All right, so coagulations. We've talked about blood clotting as those 3 steps: vascular spasm, the platelet plug formation, and the coagulation. The coagulation has its own set of steps, and it's a 3-phase process. You have to get prothrombin activator. So that's your first step. You want to get prothrombin activator, and this occurs in one of 2 ways, and we're going to talk about the 2 pathways that you can get prothrombin activator. Then you're going to convert prothrombin, so prothrombin activator is then going to cause prothrombin to be converted into an enzyme called thrombin, and then you use thrombin to turn fibrinogen into fibrin. Okay, so we're going to go into the details, so if you were like, that made no sense, it will, because now we're going to go through and define each one. All right, so when we have prothrombin activator, what we're doing, let me just skip this slide. I meant to delete that one. I apologize. We'll delete that one and the ones that you download. So the first step that you do is to get that prothrombin activator, okay? And again, to get prothrombin activator, there's 2 pathways to get it. And you can either get it using what's called an intrinsic or extrinsic pathway. And usually it's both, okay? So usually both pathways are going, but one's a little faster than the other. And these are both going to be triggered by something that's damaging the tissue, and you're going to have a series of events, okay, a series of procoagulants, and the pathway is going to get you to something called factor X, okay, and factor X is going to bind with calcium and PF3 and factor 5 to form prothrombin activator. So again, don't freak out. Let me show you what this looks like, okay. So these are your 2 pathways. This is kind of a complex process for blood coagulation. The intrinsic pathway, this is something inside the blood vessel, okay? So maybe something, a negatively charged surface, inside the blood, I'm sorry. I think I said inside the vessel. Yeah, inside the blood. So these are the factors inside the blood that cause clotting. And so you're going to see these that are may occur with when you take blood from a person and you put it in a test tube. When it is exposed to that glass, that will cause the blood to clot. which is why when you draw blood, they put those little anticoagulants in the tube so that it stays liquid so that you can get your blood test done. But there may be something inside your body, that's going through and causing this intrinsic pathway to turn on. The extrinsic pathway, these are things that are found in the tissue surrounding, so in the blood vessel. And so when they're broken, when those tissues are exposed, when that collagen is exposed, that's going to start causing this pathway as well. And it tends to be a little bit faster, which makes a lot of sense. If you cut yourself and you have an open wound, an open vessel, you need to slow that blood down even faster. So the extrinsic pathway is a little more direct, fast way to blood clot or coagulate. So the intrinsic pathway, your vessel endothelium ruptures, or you've put it in a test tube, something like that, and the chemicals actually within the blood start their cascade. And I don't ever ask my students to memorize, that 12 goes to 12A and then 11. I mean, I don't make you memorize this. Okay, what I want you to see is there's a set of these factors that start to cascade and turn each other on. Okay, so it's just this one turns on this one, this one turns on this one, this one turns on this one, this one turns on this one. Okay. The extrinsic pathway, you have a tissue factor that's released, and that causes joins with calcium and causes the change of 7 to 7A. Again, I'm not asking you to remember which one's which. What I want you to see is that eventually, okay, these both lead to factor X. Okay, and you can see that this extrinsic one is faster. There's less steps. It's less complicated. So again, for my students, I don't make you memorize all the factors. If you wind up being in hematology, or you wind up dealing with people with bleeding disorders, then yes, you may need to know that. But at this level, I don't really care that you memorize the steps. What I want you to know is that you need to get to factor X, okay, either extrinsically or intrinsically. Extrinsic's the faster way. And once you get to factor X, it's going to join with calcium and something called PF3 and give you prothrombin activator. This is our goal. Okay, we want to get prothrombin activator. So all that stuff I told you, all I need you to know is you have two ways of getting to prothrombin activator. Okay. Now that prothrombin activator, this is where that slide was supposed to be. That prothrombin activator is going to catalyze the transformation of prothrombin to thrombin. Okay, so prothrombin activator causes prothrombin to become thrombin. Okay, so it catalyzes that reaction. Now, once you have thrombin, thrombin is going to allow you to form fibrin. It catalyzes the reaction of fibrinogen to fibrin. So fibrinogen, this is soluble. This is floating around in your blood all the time, but it doesn't stick. It doesn't make a net. But when thrombin is in the area, it will cause fibrinogen to convert to fibrin, which is insoluble, and it forms the net. Okay? And so now this fibrin can start to make that cross-linked fibrin mesh. So you've got to make prothrombin activator in one of two ways, the intrinsic or extrinsic pathways. So you get the factor X, which then joins with calcium. You get the prothrombin activator. Prothrombin activator then causes prothrombin to make thrombin, and then the thrombin will allow fibrinogen to form fibrin. Okay, and so when people have bleeding disorders, they will do blood tests to see, what your pro time is. What they're looking for is how these cascades are working, how quickly you can clot blood. Which of these factors you have and which factors maybe you're missing. So that's what they're looking for in people with bleeding disorders. So now that we have that fibrin, we can make that fibrin mesh. So again, that fibrin is just the structural net. Okay, so that's what all this stuff is, fibers that make a net. And that causes the plasma to kind of slow down and it becomes more gel-like and you get the clot. What I like about fibrin is, again, it's really strong and it helps to stabilize. And it doesn't take very long for this fibrin net to occur. And if you ever cut yourself and you get that scab, that's what that is. That's just fibrin with that's kind of caught all those red blood cells and that gel-like plasma to form a scab. So once you've stopped the bleeding, okay, you stop the bleeding, now you want to start to repair the vessel. That's, the goal of anything is to get us back in homeostasis, not hemostasis, homeostasis, and get us back to our normal uh, daily duties and everything working like it should. And so once you've stopped the blood, you're no longer bleeding, you're going to start to do things to start to repair that vessel so that it will be whole again. And if you remember from muscle contraction, we talked about actin and myosin. You actually have this associated with your platelets, and so it'll start to pull on those fibrin strands and start to squeeze the serum out, so get all the liquid form out, and start to bring those vessels together. So it's kind of like you're taking your fibrin and you're taking the actin and myosin, and it's almost like a muscle contraction, and pulling the vessel closer and closer so it can then be in contact. The edges can come together and they can start to heal. So that's pretty cool. You have something called platelet-derived growth factor, and that will or PDGF, and that will, which comes from platelets, that will cause mitosis to occur in those smooth muscle cells and fibroblasts. So that'll start to rebuild the vessel wall. So platelets are important not only in stopping the blood, but also getting the blood vessel to heal itself. Your endothelial cells, they also produce something called VEGF, or vascular endothelial growth factor, and they play a role in causing those endothelial cells to multiply and start to undergo mitosis and start to build more endothelial tissue. So your platelets and your endothelial cells both produce growth factors, which cause those parts of the vessel to grow and heal. Now, you don't want this clot forever. You need to get it out of the way because you don't want to have any kind of clot that would impede blood flow to an area and cause something to become hypoxic or ischemic. So you need to get rid of it after it's healed. And so usually within 48 hours, you're going to start to get rid of that clot. And there's something called plasminogen in the clot, and it's going to be converted to plasmin by something called TPA, or tissue plasminogen activator, factor 12 and thrombin. And so what you need to know is within 48 hours you get the production of plasmin by this TPA. And plasmin is a fibrin digesting enzyme, so it breaks down the net, so that way now blood can start to flow. TPA is that thing that they give you if you've had a stroke. A lot of times when someone's had a stroke, they've got a clot. And so if you think someone's had a stroke, get them to the emergency room as soon as possible so they can give them TPA, which can cause the formation of plasmin, which can break down that clot quickly and hopefully repair or restore blood flow to the brain and hopefully reduce the effects of the stroke. So that's what you've heard of TPA. That may be where you've heard of it before. All right, so that's all I'm going to talk about right now. We're going to continue in our next video with bleeding disorders. Thank you.